Good evening, all 10th standard student. Welcome in my channel Alchemy N. As you know that we have started our lesson number 2 of chemistry, periodic classification of element. And from that lesson, we have completed 2 points. Earlier we have seen in the 2 videos. In today's video, we are going to start the point number 3, that is called as Newlands law of octave. So the first question starts with, what is Newlands law of octave? Everything we are going to understand about this Newlands law of octave. But okay, first question rises in the minds of different students. What is that Newlands law of octave? So Newland, he was the scientist, English scientist, and his name was John Newland, and he tried to classify the known element under the nodes of music, that is called as octave. So Newland, he was the second person after Dobereiner. You know Dobereiner, he tried to classify the element and he had given the name of his classification as Dobereiner's triad. After Dobereiner, Newland also tried to classify the element according to his own method. That method is called as Newland's law of octave. Octave means 7 notes in music, like sa, re, ga, ma, pa, dha, ni, and sa will again come, it becomes 8. Actually 7 notes are there, but okay, if we are counting again sa, because sa, re, ga, ma, pa, dha, ni, sa, we are again coming to the sa, it becomes 8. So he classified all the element under the 7 notes of music. Therefore he called as, okay, because the 8th element comes once again to the sa. Therefore this method of classification is known as Newland's law of octave. Then let us try to understand the important points regarding with this Newland's law of octave. First, name. What was the name of this Newland? The name of this Newland was John Newland, and he was English scientist. Okay. Then point number 2, he arranged the element on the basis of their atomic masses. This is very important. Newland classified element on the basis of atomic masses. Point number 3, Newland arranged the known element at that time in 1866. In 1866, Newland arranged near about 56 element. This point is very important. Near about in 1866, Newland arranged near about 56 element in an increasing order of their atomic masses. Now point number 3, his classification, he started with very lightest element. Point number 4, he started his classification with lightest element hydrogen, and he ended his classification with one metal that is known as thorium. So what we learn from point number 4, Newland started his classification with the lightest element hydrogen, and he ended his classification with one of the metal that is known as thorium. Then he arranged element hydrogen up to thorium in the increasing order of their atomic masses. Then he found that some new things. Point number 5. What he found that? Point number 5. What he found that? He found that every eighth element, element number 1, 2, 3, 4, 5, 6, 7 and 8. Every eighth element had properties similar to those of the first element. He found that the property of eighth element and property of first element, it was similar. They were showing similar property. That was the finding of Newland. For example, sodium is the eighth element from lithium. I have written on the board. You can see from the board. Sodium, that is the eighth element from lithium. Lithium upside under the node ray. Lithium is there. Below that you can see sodium is there. So sodium is the eighth element from lithium, and sodium and lithium, both they are showing lithium and sodium. Sodium is the eighth, lithium is the first. Sodium and lithium, both they are showing same properties, similar properties. Also, magnesium shows, magnesium metal, magnesium shows similarity, otherwise similar property with beryllium. You can see from the board, magnesium and beryllium. Okay, magnesium shows similar property to the beryllium. One more example we will take. Chlorine. Chlorine shows similar property with bromine. Chlorine here under the node of Sa. Here you can see chlorine shows similar property with the fluorine. So this was the findings of Newland that we have seen. What he find out? He find out that properties of eighth element and properties of first element, these were similar property. Okay. Then point number 6, he called the similarity observed in eighth element and the first element. He called the similarity observed in the eighth element and the first element as a law of octave. This is important. What is law of octave? Law of octave is the similarity which we are finding in the eighth element and in the first element. That is known as law of octave. Here you can see the table. I will tell you. Okay. Under hydrogen, you can see Sa. Here at backside I have written the table. You can see hydrogen, fluorine, properties will be similar. Lithium, sodium, properties will be similar. Beryllium, magnesium, properties will be similar. Boron, aluminium, properties will be similar, because now what we are taking, hydrogen is the first element, fluorine is the eighth element, lithium is the first element, sodium is the second element. You can count, you can check the element, then you will understand. Beryllium is the first element, magnesium is the eighth element, boron is the suppose first element, aluminium is the eighth element. Likewise, okay, the first element and element number 8 from that first element, they are showing their similar property. So this similarity observed by Newland, and he called this similarity as a law of octave. Very good. I hope you understand. And this table I have written on this board. This is very important for you. Okay. But one thing is there, up to calcium, this table, what he prepared, his table was limited up to calcium. Finish. His table was limited up to calcium. After calcium, whatever the elements he had given. So after calcium element, Newlands law of octave, that was not applicable. This is one of the things. Okay, his table was limited up to calcium only. From textbook, you can see the table, you will understand. So these 5 points are very important as we have discussed related with Newlands law of octave. Along with this table you have to verify very properly. Then last point related with Newlands law of octave is some drawbacks were there. Okay, so let us study some limitations were there. So that is called as limitations in the Newlands octave. So one by one we will try to know which were that limitations. Some drawbacks were there. He had done very good work because he was the second person. He tried to classify 56 total element, but okay, in his Newlands law of octave, some drawbacks were there. First drawback, that is, okay, this law was found to be applicable up to calcium metal. This is the first drawback. This is the first limitation. Newlands law was found to be applicable up to the element calcium. Okay. Drawback number second, Newland fitted all the known element in 7 into 8, that is 56 boxes. Newland kept all the 56 element in one box. So Newland kept all his element in the 56 boxes. One element, one box. One element, one box. Okay. Then drawback number third. But according to drawback number third, according to limitation number third, Newland placed 2 elements in some of the boxes with different property. Okay, Newland placed 2 elements in some boxes. For example, Newland placed cobalt and nickel in one box. For example, Newland kept cerium Ce and lanthanum in one box. So this was the drawback. Then again, drawback number 4. He placed some element. Number 4. He placed some element with a different property. He placed some element with the different property under the same node. Under the same node, he placed the element with different property, but under the same node. For example, let us see one example is there. Okay, cobalt and nickel both are showing same property, but he kept cobalt and nickel under the node Do. Okay, Indian node, that is Sa. He kept cobalt and nickel under the node Do. Under the note Do, that is Indian music note, that is Sa. Okay, but if we observe this drawback, then we can find out that cobalt and nickel, except cobalt and nickel under the Sa, hydrogen, fluorine, chlorine and bromine, most of the non-metals are there. So this was his drawback. Again, along with oxygen and the sulfur, here T note you can see, Saregama Pada Ni, under the Ni or Ti note you can see. Along with oxygen and the sulfur, Newland kept ferrous, Fe. So that was the drawback of Newland. Okay. And then Newland's octave did not have provision to accommodate the newly discovered element. Whatever the in future the elements will be discovered, then he could not give place in the Newlands octave. So whatever we are observing, these are the 5 to 6 limitations we can get in the Newlands law of octave. So this question will go for approximately 3 marks. So first we have to observe the Newlands law of octave. In that, name of Newland, that is John Newland, how he placed element on the basis of their atomic masses. In the year 1866, he arranged element in the increasing order of their atomic masses. He started element with hydrogen, ends with thorium, then hydrogen, fluorine, lithium, sodium, beryllium, magnesium. Okay, they are showing same property. Like that you have to write in the examination. And one more thing, don't forget, along with this you have to write law of octave. Table also you have to draw in the examination, but law of octave, what is that? The similarity observed in the 8th element and the first element, that is known as law of octave. Along with that, the separate question will be there on the drawbacks or limitations of Newlands octave. So in this topic, in this video, in this topic means in this point, we have to stop here. Tomorrow with the same energy we will start new point, that is Mendeleev's periodic table. Hope student you understood today's point, that is Newlands law of octave. If you are not understanding, then also please give me comments about Newlands law of octave. Here's a table I have shown on the board and limitations of Newlands law of octave. Then once again we will discuss. Thank you. Keep watching my channel Alchemy, and thank you.